Geometric sequences, task card activity, lots of practice. Let's learn something new. Learning intentions. Students can write terms of a geometric sequence. Students can use the formula for the general term of a geometric sequence. Students can write an equation for a geometric sequence given the initial value and the common ratio. Students can use a created contextual formula to solve application problems. Task card number 1. Use the sequence below to complete each task. We're going from 5 to 10 to 20. Let's see what our common ratio is. 10 divided by 5 is 2. Common ratio is 2. Explicit formula. Here we go. Let's plug in our values. Initial value 5, common ratio 2. And now we need to find the nth term as being the 9th term. So a sub 9, plug in 9 for the ends and calculate. You get 1,280. Next, one card 2. Sequence below 3, negative 15, 75. Let's see what our common ratio is. Negative 15 divided by 3 is negative 5. Initial value is 3. Going into our explicit formula, common ratios negative 5. We need to find the 5th term. So in place of the ends, we're putting in 5s. Put it in your calculator. You get 1,875. Task card number 3. Our sequence is 972, 324, 108. Need to find our common ratio. Divide 324 by 972. Simplify. You get 1/3. So R is 1/3. That's our common ratio. Explicit formula. All we need is our initial value, a sub 1, and our common ratio, R. Plug it in. There we go. We want the 6th term. So in place of the ends, put in 6s, put it in your calculator, and I would probably recommend instead of putting 6 minus 1 in parentheses, just go ahead and put 5. So much easier, less likely to make a mistake. And A is going to be 4 when we're looking for the 6th value. Task card number 4. Use the sequence below to complete each task. Sequence is -2, 8, -32. We need to find our common ratio. 8 divided by -2 is -4. R is -4. We are using our explicit formula, plugging in our a sub 1 and our R, the initial term, and our common ratio, and we need the 10th term. So in place of the ends, put in a 10, put it in your calculator, and 524,288 would be the 10th term in that sequence. Geometric sequence, task card number 5. Sequence below is 2, 14, 98. Let's see what our common ratio is. 14 divided by 2 is 7. Common ratio is 7. Use our explicit formula. Initial term is 2. R is 7. Plug it in. We want the 5th term. In place of the ends, put in 5. Of course, our exponent is going to be 4. Plug it in your calculator. You should get 4,802. Geometric sequence, task card number 6. Use the sequence below to complete each task. 1,536, 768, 384. Find the common ratio, write your equation, find the 8th term. Common ratio, divide 768 by 1,536. Simplify, we get 1/3. That is what our common ratio is. We're using the explicit formula, plugging in our initial value and our common ratio. There's the formula. Now we need the 8th term. So plug in 8 for each of the ends and calculate. We end up with 512 over 729. Number 7. Here's our sequence. -5, 15, -45. Find our common ratio. 15 divided by -5. We get -3. Use our explicit formula, initial values -5, common ratios -3. We want the 12th term. So we're putting 12 in place of the ends. Calculate. Exponent is going to be 11. Put it in that way. It's probably going to be helpful. A sub 12, the 12th term in this sequence, 885,735. Number 8. Here we go. 7,680, 1,920, 480. Divide to get our common ratio. 1,920 divided by 7,680. Simplify, we get 1/4. Explicit formula, plug our values in. Initial values 7,680 and our common ratio is 1/4. We need the 6th term. So in place of our ends, we're putting in a 6. Put it in our calculator. Exponent, of course, is going to be 5, and we get 7.5. Number 9, a little bit different. A computer virus initially infects one file. That is our initial term. Then the total number of files infected triples every minute. So our common ratio was 3. So to get the next term, you multiply 1 by 3. To get the next term, you multiply 3 by 3. Equation, explicit form. The initial value is 1. The common ratio is 3. Plug that in. We want to know how many files will be infected after 15 minutes, and it is tripling after every minute, so our units are the same. So plug in 15 for our ends, and we get 4,782,969 files in 15 minutes. Number 10. A ball is dropped from a height of 1,600 meters. Each time the ball bounces, it reaches 3/4 of its original height. We need to find the first 3 terms of the sequence, write the equation, and find the height after 4 bounces. So R is 3/4. First term is 1,600. And multiply that by 3/4, we get the next term. Multiply the 1,200 by 3/4, we get the 3rd term. We could just do it again to get the 4th term, but they also want an equation. So explicit formula, initial value 1,600, common ratios 3/4, 4th term, plug in a 4 in place of our ends, put it in our calculator. Calculate that exponent is going to be 3, and we get 675 meters. Number 11. Madison started a bank account with $200. Each year she earns 5% in interest, which means the amount of money in the account is multiplied by 1.05 each year. This is a yearly event. So R is 1.05, first 3 terms. Starts with 200. Multiply that by 1.05. You're at 210. So it's not increasing a lot. It's only 5%. but there's not that much to begin with. If we do it again, we're at $220.50. Our equation needs the initial value of 200 and our common ratio of 1.05. 10 years is what we're trying to calculate. So in place of n, put in a 10 and put it in your calculator. Exponents 9. We get $310.27 after 10 years. Number 12, car depreciates by 20% each year after it's purchased, which means it retains 80% of its value. Depreciates by 20%. Table below shows the value of the car over the first 3 years. Okay, so 1 year is $12,000. Year 2 is at $9,600. Year 3 is at $7,680. So our common ratio, we need to divide the $9,600 by the $12,000, which is retaining the 80%. So that verifies depreciate by 20, retains 80%. Let's get our equation. Explicit form. Initial value is 12,000, retaining 80% every year. And we want the 8th year. So in place of our n's, put 8, our exponent 7, and put it in our calculator. The value of the car went way down after 8 years, $2,516.58. We have now finished the task card activity for geometric sequences.